Hey, have you been hearing this term context engineering for the last 2 years and wondering actually what is context? Well, if so, this video is for you. I'm actually going to break down how context works actually under the hood. Doesn't matter if you're not technical or not, I will really break this down with some examples and some visual aid so you can really understand how context works under the hood. Why are there some trade offs and why do we have this issue of things getting lost in the middle? And why does it focus on one things over another? Anyway, so we're going to really break this down as simple as possible so you really understand how context works. And with knowing everything at the lower level, you can then understand how things work and you can actually build your context in a way that actually matters. All right, just to start with, we all kind of know what a context window is. It's kind of broken up into these chunks. It's got your system prompt, your tools, and then your user request, and then whatever the AI comes back with a response, that's also put into the context window. One thing that we do see quite often is as context grows, we see performance decrease. And why actually is that? What is actually going on here? And the reason is actually how context works under the hood. The more you start to understand it, the more apparent this actually becomes to be. So let's just jump into how context works. So just quickly is if you've got input tokens, you need to pretty much convert them into embeddings. And then in those embeddings, you're going to put them into the query position, the key positions, which is like a vector. And then that determines like the weight matrix. And then we kind of generate new thoughts from that. And then we pass it from one layer to another. Anyway, I probably lost most of you with that quick example. But how this actually works, let's just do a metaphor here. So let's just assume we have a classroom, all right? So to make this a bit more simpler, imagine we have a classroom. And in that classroom, we've got kids, we've got a teacher, and we've got a bunch of tables, all right? And this classroom can only hold about 20 kids. Imagine that's the context limit. If we get any more than 20 kids, we can't really hold everything in the classroom for those 20 kids. Anyway, so these kids each have a word. So you can think of that as a token in the string. And the kid walks up to the teacher and says, "Hey, I have a certain word that I need to figure out. Maybe that's the string that we want to compute." And the teacher will then break that into different three blocks, one being V1, K1, and Q1. And what do these blocks represent? Essentially, we can think of like Q is the query, like what do I actually need? What am I looking for? K is like the key, how do other people find me? Like, hey, what is my key position? And V, what value? What can I share? Like, how valuable is the thing that I can share about this? And that's all computed from that word that the kid is using. So this kid could just have, you could just make a word one, for example, and in the school that could have certain value and a certain pretense. Maybe we can make this a little bit different, like lion, for example. And that could have a lot of different other values. It could have a certain way that the school looks at it. Um, what am I looking for? Is it meat? What is that? So his word here is lion. He passes to the teacher. The teacher has a bunch of calculations on how to calculate each of these, and then passes it back to the boy. Says, "Okay, here's your Q1, and here is your calculated values. Go put on the table over here." So the little boy will go put his K and his B1 onto the table on the specified locations, and he'll keep his Q1 and walk aside and wait with his Q1. The next boy will come across and he will have a different word, whatever word that could be. Let's just make it fish, for example. None of these are making much sense, but all right. So the second boy comes and his word is fish. He asks the teacher to again calculate each one, and she calculates a Q for him. This will be Q2, and okay, this will be K2, and another value. All right, and this little boy will then go put these on the tables, and he will walk over here, and he'll keep his Q2. And the third boy will also come across and he'll have a new word. This is to tiger for this one. Again, the teacher will say, "Okay, this is your new value here. So we'll do this be 3, and this will be your Q. Right, and this little boy will then put the K3 on the table, you put the V3 on the table, and again, he'll walk and join the other boys while holding his new Q3. Right, so this will carry on until we kind of fit our context, but assume this a little section here, these three boys, is the first layer. And say this was just the system prompt, the tools, and the user input in this example. So we've kind of got our first layer of our K and V. And what's actually quite important about these two things here is if you know anything about prompt caching, this is actually what this represents. It's this actual calculation is cached. And this is why it's a lot cheaper because you don't need to run this compute each time for this cached layer. Anyway, but this is only the first layer of an LLM. There's multiple layers of this. So how does this work? This is where the term self-reflection comes in. And pretty much we tell boy one, hey, you need to generate a new thought on what you see here. So the boy one will walk to the table. All right, so our boy will come here and the teacher will tell this new boy, hey, you need to think of a new thought. What he will start doing is he'll start looking at all these Ks to see how relevant are they to his initial, question here, like what is he trying to figure out? And maybe he decides, K1, his original one, is only worth zero point 0.1, K2 is maybe zero point 0.5, and K3 is zero point 0.4. And then he kind of generates a new thought from that. So how does that actually look? So it looks pretty much like this. So he comes in with the Q4 and he generates different values to generate this new thought. And each gets an intention score, and that generates a new value. So because this new boy has looked at all these different weights here, this new thought changes. So the teacher then looks at every little point that the boy made and then tries to compute the weights for each. So he gets a new thought here. And then what happens is this little boy exits the classroom, but one thing you'll see here the K and the V still stays on the table. And it'll be the second boy's chance to develop a new thought. Again, he will look at the Ks on the table, determine which ones are relevant to his question, and then he will come up with the new thought himself and move out of the classroom. Just remember, this classroom can only take 20 kids, so the tables here are representing that classroom fit. So if more than 20 kids come in, it can't fit on the table. Essentially, this new boy will go with his new thought with the first one. And the cycle will kind of repeat. They will go to a different classroom, go to the teacher, generate um, new Qs and new K1s and V1s, and put each one on the table for each individual step. And what's interesting is this will keep happening until the end, where they'll generate the last final thought, and that will, they'll probably present that to the principal, which is pretty much the response that comes out here. And that's generally how it works. But what happens if we have a new request that comes in? So we send a new message. So essentially, what that actually is now is that is a new boy. So think of that: a new boy walks into the classroom and he's got a new word here. And this is he doesn't care about animals and it's water. All right. And then the teacher again will give him a V1 and he'll put that somewhere on the table. He'll put a new KV on the table and he will go again and try to generate a new thought from the K at the Q1 that the teacher generates. So he'll look at this one. Okay, what am I trying to figure out? What's my question? And again, he will look at the Ks here and then generate a new thought. All right. So I've kind of just demonstrated how this context work under the hood in terms of the machines here to help you visualize this whole scenario. But this is where it becomes really apparent, where the more context you give, the harder it is to focus. So every time these new thoughts are generated, the boy can see the full table. So he can choose any of these weights. It's not like it's obstructed. He's got a clear view of all of them. But maybe habit has always been part of this little boy's identity that he always picks the closest and the furthest one away from him the whole time. He's always told by his parents, always try to choose the outliers. They got the best results. And for whatever reason, it's a bias in his system that he always chooses that way. And that's why the weights will always be higher. And this kind of happens in training data because if you think about how do we actually train a model, we give it a question and an output that it um, needs to give us. So it's always like the first token in and the last token out is kind of where we expect things to be. And this kind of behavior is demonstrated here. And remember, this is trying to find the weights of each one that associate to the query. And that's why wording and why the words are so important in your context to really get the same result. There are a lot of different layers to this to try help with thinking. So you might have smaller classrooms that are those thinking tokens to generate different thoughts, to get different perspectives, and then pull all that together in the last layer. So hopefully you start to understand how all of this is coming together in terms of just the LM, the context side. And this is why also things get lost in the middle in terms of context. So you might have a long paragraph and then things in the middle might be very important, but are overshadowed because we have trained models to always focus on the first and last bits of the context mostly just because of the training data. And that's like the main focus. But also kind of tells you if you give it a large bit of context and it's all scattered around, um, it also shows if you do give a bit of context and the context is scattered in terms of what it's actually talking about, it's very hard to get reliable results because each thought that is generated is probably picking on maybe other parts of the section to generate those new thoughts. And the irrelevant thoughts might not even matter. Or I say irrelevant, maybe they are extremely relevant, but it's scattered and doesn't actually form a basis of what's important for that context. Hope you enjoyed this video. It was just a quick one. I just really found it was kind of interesting to understand how context works under the hood and actually visualize it and have a metaphor so you can actually understand how context is coming in, how even caching is working, because that's those K's and V's at each classroom layer, and how this actually impacts each token coming in after it, and why the first bit of tokens that you actually put into your prompt are so valuable, especially like the system prompt, things like that, it starts becoming a lot more clear because that actually influences every other token that you put in. Anyway, hope you guys enjoyed this video. Thank you guys so much for watching, and I'll see you in the next video.